Hello and welcome. I'm Bill Wake. We're working this week on Parser Combinators, which is a functional language approach to parsers. It looks like it creates pretty nice readable parsers that look very much like their grammars. We've done a lot of experiments so far, and I want to move from kind of spike mode to TDD mode. So go from experiments into more kind of coming up with a production version of this. I do have a couple more experiments though. Let's see. I watched a couple of videos. These are from WWDC 22, Embrace Swift Generics and Design Protocol Interfaces. And both of them, they're talking about using the sum keyword that we used the other day. And then there's an any keyword that is coming out in Swift 5.7. I don't think we have access to any yet, but we do have access to some. So I thought before we left experiments, we'd try a couple more. Let's see. So we got to open recent. I think our original playground, maybe. All right. So in this version of the combinators, well, they all define a parser a protocol parser. It's got a target type, and then they parse from array of characters and a position, giving us a target value and an integer. Where we got balled up, well, I think it was OrElse. Okay, where's OrElse? There we go. Okay, so our target, yeah, so we had this OrElse, and we tried this notion of sum, and it was by analogy to Swift UI, because what happens is we get balled up in matching types. Let's go down to the examples. Okay, so we were doing this arithmetic expression one, and we have NF. This is, we've simplified greatly, but NF takes a digit and then makes a number out of it. The number is, our parse tree has number nodes and operator nodes. We're just doing one that's simple digits or digits surrounded by parentheses. And the problem here is we would like to say, no, wait a minute. Well, we'd like to say this. Is that okay? Yeah, that gets messed up. Okay, because the type of NF is pipe, and the type of this one is a bunch of and thens. Okay, and it looks at that and it says, I don't think your types really match. So I think what I can try is, well, I think two things. One is, I've said they have to be the same parser type. Well, they don't really. Okay, I think what we want to do, we want to say P1 is a parser and P2 is a parser, and I think we put it here, where P1.target equals P2.target. Okay. I may have messed up the syntax, but so we want to constrain. Yeah, definitely messed up the syntax. Oh, well, these are all. This is the one that's messed up. Closure expression unused. Okay, let's find an example of. Well, we might have one with and then. Parser 1, P2, parser. No, we didn't constrain it there. Okay. Do we have any? Yeah, that one. No. Okay. Let's see if we can find Swift generic with where constraint. Okay. these are quite what I want. Okay. Swift constraints on generics. I don't know. There's only showing it on extensions. We're closing generic context. That sounds more promising. Struct wrapper. I don't want to do an extension. Maybe I'm just backwards in the order. Maybe parser comes first. Turns a parser. Okay. Cannot find P, P1, P2, 2. Okay. I think we can say target here. This is requiring them to be the same. That's not quite what we want. Okay. We're still messed up on this line. Let's try and run here and see if it gets okay. Yeah, ambiguous without more context. Okay. Or else they're just a little too big. Okay, so I think our operator should be the same to OrElse P1, P2. I don't mind that. Cannot find P2 in scope. I don't know. They should be allowed to be different. Protocol parser as a type cannot conform to the protocol itself. Only concretes. I don't know what that means. Okay, let's not worry about this one for a while. Or else that's P. Okay, can I do this with P? P. Okay. Now I'm going to take this one out because I'm not convinced I've got that straight. But let F equal, let's say, or else NFPE. Does that compile? Yes. Okay, now can we make our operator do it? I hate all this boilerplate for this. I wish there was a... I guess if I wanted named thing, could tolerate named fields, I could have it. Right. So the problem is, I think this is requiring the parsers to match. Okay, so function this. Maybe this P1 parser, P2 of parser, and then somewhere I have to say where, but this is P1 and P2. The type is OrElse P1, P2, and that's OrElse. Does that make sense? Okay. Now let's go down here again. F. Okay, so let me see if F is also happy with OrElse. Let's add it again. Why does it fall apart there? Get it. Okay, let's stop and run. Yeah, it's one of those little temporary errors, I guess. Okay, this seems better. Optional 272. Okay. Now let's try the operators. Oh, we seem to be better. Okay, and let's mix in D, and I think this should complain. The message isn't going to be very helpful. D is digit. I guess I could say digit. Right. Right. So pipe, we can't pipe. Sorry, we can't OR together a parser that produces expr with one that produces string because they're just not compatible. You got to produce one thing or the other. Okay, but if I do NF again, let's try that again. Oh, I don't care about that. However, this does bug me. 6. No, okay, good. All right, I think we did it. So the bottom line of it is I didn't have the right constraints on my class. We basically added this constraint. So, golly. Well, that makes me feel good. We can get something. We don't need all that wrap stuff. Okay, so that we could we could allow it, but we don't need it, I don't think. So that's a good step forward. Okay, I'm really happy about that. The any and the sum, there is something there, but it's not in the current version of Swift that I have. It's in beta release now. And what I thought I would have to do, I said some. Let's see, where did I do this? Okay. I tried doing some target orient. I think it may be that the arguments here maybe could be some P1, some P2, or something like that. Some parser. We're trying not to care exactly which type, but I think this did it because we have two types. The targets are the same, but the types are different. Let me go down there again. Okay, so where's F? In F. Okay. See, their rightmost type, that's the target of this thing, is expr, and then this one is also expr. So it kind of hangs together that's the part we cared about, and my constraints just didn't do it. Okay, well that's good. So knowing that, I feel better. What else was I worried about? I guess the other one I worried about was also in this version we had. We have an and then parser. Well, we introduced and then array. And then array. Oh, let's see. I guess what we're trying to do is, instead of returning a pair, we're returning an array of two elements. And then we tried the operators. Okay, this one we commented out. If you have P1, P2, the exact same type, then you can create an AND array, and I think we did some of that. Digit and plus, I think that may be an and then array. Okay, and so the result of this thing is an array of two values and a position. And this one should be an and then array. Oh, this is an and then of an and then array. That's the trick. The problem is these two form an and then array because they're the same type. They're both simple matches. But the and then array is a type array of stuff, array of match. Match.target, which in this case is string or character, I can't remember which. But in any case, this type, when it tries to match this digit or plus, let's see, I guess I could say it this way. Let xx3 equal xx append to it digit xx is and then array. This is just a match. So our and then array code here can't trigger because P has to be equal P for this one. But let's see if we can, let's try another version. If you take P1 of parser and, P1 of parser, P2 of parser, I forget where you put the wheres, but P2 parser bracket, yeah, parent. Okay, let's just take the rest. Function dot P1 of P1, P2 of P2. Is it where P1 dot target? equals it's not p2.target because array. Something's messed up. Well, sure, that's fine. No, that's not what we want. I want to find an example where the where clause is on the function. Compare this to that where something. But we don't have a return value. Oh, the where clause can't apply to the function definition. I'm just not seeing it. It's close. Okay. Yeah, so what I'm looking for is I would like to say two things the same type go to an and then array. Two things where the first type is an array of X and the second type is X goes to an and then array. I don't know if they can be the same type or not. I mean, let's see, where do I have a where clause? Where else would be one target? Okay, let's take one little research tour here. Swift where clause. Maybe we can find the official documentation. Extensions with a generic where clause. Item is equatable. I really want to get the array type's interior type, and I don't know if I can do that. Oh, I bet I can, right? It's called array type dot. Oh, I did have array up here. Array. Like, how do you get to this? It's not associated type, unfortunately. I don't know. Elements, arrays. It's not self, right? That's Um, that's not it. Okay, good question. Self versus self. Return type of the class is the type of the. Yeah, thank you. I can't constrain that. Huh. Okay. Okay. Well, I bet there's a way, but I just don't know it. Somehow, I would like to say, let's find it in an array. I'd like to make one of these where P is I want to somehow get to target dot something dot that. And is it dot element? Let's try and make one. And then array 2. P is a parser. I guess we had a P1, P2, right? P1 is a parser. P2 is a parser. The whole thing returns or subclass as parser. Okay. And then parser. Well, what's the difference here? Oh, parens. Okay. And then our where clause. After the declaration, okay. Where P1 dot target dot element? No. Does not conform to, okay, that's fine. Target equals P1 dot P1. Element is not a member of P1 at target. Parser. Okay, can we specialize parser? We have its target. I don't know if I can do this. And P1 dot. Well, let's try that much. Can I say that? Yeah. A reference to generic type requires. Okay. And well, maybe that's right. I don't know. Okay, the declaration seems okay. I don't know if I can get P2 in there, though. Can I make another type in there? No. Array of any. It seems like I'm turning generic when I don't really want to, but let's, well, let's take this stuff. Okay, target pos equals P1 parse. Oh, we got to init. Which is going to look a lot like this. Except 1 and 2. 1 and 2. Okay. P1 parse. Now this is target 1 is not nil, and we know it's an array, so I don't think I've completely constrained it, but I can one dot append target to bang. This is probably a bang. Type nothing int, type p1, optional int. Turn time, cannot use a mutating member on an immutable value. Target one is a let constants. Turn expression of type nothing int to p1 int. Target 2 is p2.target. Return expression target 1.append. It seems to recognize that target 1 is an array because it suggested append. See what the type is. Void. Why are you void? Yeah. Okay, I think this is P1. Target 1 is array of any optional. Okay. So this should be array of any. Target 2 should be something else. P2.target. Oh. No. Well, I had array documentation up. Do I still have it? Array. Adding elements. Adds a new. Mutates it. T1 is the target array. If I do T1.append, oh, and append doesn't return the thing. Okay. Any int to P1 int. Array of p2.target, would that work? Array of p2.target. a parser P1. Sorry. Let's hit this stuff. So what is it going to say? P1 optional. But that doesn't seem right, does it? I mean, target is string. Parse returns string. So I've got my target wrong. Equals P1 array of P1 dot target. Well, maybe it's array of P2 dot target. It should be offering to generate something for me. Yeah, I don't care about that. Why are you happy with P1.target here? I thought that should be this. Okay, that's compiling. Okay, what do we got here? This takes an array of stuff and produces an array of stuff. Okay. And we can clean that up some, but the question is, can I define this? I don't know, can I put a where clause in here? Can I convert value of P2 to P2? And then array 2. Will that work? With too few parameters. Got one. Oh, yeah, P2. Okay. Are we there? Where's my examples? Okay. Type of XX should be and then array. Type of this one should be and then array 2 of and then array of match. Yeah, because it took the and then array, and this one should be the same. Okay, now if I want to make XX4, XX3, append another digit. And then array 2. This might be working. Okay. So what I think I've done is if you and a series of compatible types, we create an array of those. Okay. Even though I've got these two different types, I don't know if there's a way to fold them together, and there's details. But I do think the end result is, and then array 2 is an array of stuff. Let's see, where is that thing? And we know the target is an array of stuff. So I think we can. let's go down here. So we have make op. Oh, these are three separate things. Oh, we have make number here. This one. NF. Oh, that doesn't come into play, does it? Okay, well, the type of PE does. Pipe to exper. So this thing produces an exper. And NF produces an exper, and we are allowed to merge them together. I think it's helpful. Now this, because these types are not the same, let's see. Yeah, these are and thens, not and then arrays. Okay, so we have, if you do incompatible types, you get tuples back. If you do compatible types, we'll give you an array back. And if you do a series of things to an array, we still give you an array back, I believe. That's what we're going to learn. All right. That puts us, I think that's the only thing I was curious about at this point. Let's see. So, oh no, one more thing. Okay. So the things we learned, if you use type constraints, you can make OrElse work as we want without wrapping. That's good news. Okay. Another one is with a modest bit of work, you can make it so sequences of compatible, let's say identical types return an array of that type. If not identical, returns a tuple. Okay. Now the last piece, so up till now, I think this is true for all these that we did. Our parser, oh man, I think I just froze. I did this the other day too, trying to show this to some friends, and every time I scrolled fast to the top, it crashed. All right, fine. Can I get over to the other window? Can I save? Who knows? Okay, let's restart that bugger. Force quit. Xcode. Force quit. And I don't know. It's a real pity to me for the playground to be bad, because I don't know. I think beginners are probably going to lean on the playground a pretty fair bit. All right, that's this. Let's save that. And we had this. Is this Pecan? What is this? Pecan.playground. Okay. All right. So, yeah, let's see. I was saying, yeah, the parser, we assumed array of characters. Well, in our application in the basic interpreter, it's going to be an array of tokens. And so one question in my mind is, can we make this type generic across, I'd rather make it token if I can. The other question in my mind is this int the right thing to use? So we have arrays, like we could do slices. So if I passed a slice of an array in here, I could just pass it as if it were an array, I think. I may have to say slice, I don't know. And then here, instead of, I wouldn't need this integer index because we would only pass the slice of the remaining characters, so, or tokens or whatever they are. And then this would become a new slice. So we saw one parser that did string goes to target comma string. We're thinking about something on that order. I don't know what's involved in making a slice argument, but it probably is on this page. Subscript of range. Okay. I can get an array slice. Right. So it has a start index, I think. It should have start index, end index. Let's see. Oh yeah. To refer to the ending slice, use start and end index. Okay. So I think that seems straightforward enough. We can probably just do it. I think if you pass the array, you probably pass array 0 dot 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 or something. Let's see if anybody has an answer for that. Swift convert array to slice. Cast the slice using array of slice. Range, yeah. The array slice continues to store the original elements. Oh, interesting. Okay. Slice maintains the indices. Okay. Slice of 0. Oh. Interesting. Okay. So I had assumed it would map across 0, but okay. Well, that's good to know. We probably can do slice first and stuff like that. How to create an array slice. Well, we don't want to drop. Oh, maybe we can. That didn't work out. Oh, there we go. Drop while. Okay. I guess we got that subscript. We can do it that way. The unfortunate thing, I really wish I could just pass the array into the slice. Maybe you can. I don't know. It could have converted automatically. All right. Well, I think that open question arrays are results from a series of sequence operators. Yes, we did that. Okay, so let's record this for today. We learned these two things. I guess we can put the question and then the answer. Okay. And input stream, can it be tokens? Yeah, I think we want to do try array slice. Okay. And I think that will do it. All right. So I think we want to pick up here. We want to create a package and build basically a library for this stuff. And now we're going to do TDD mode and do it properly, if you will. Test it along the way, make sure it really works, not just kind of the little dibble-dabble testing we did in the playground. But I think we're okay. I think we've got enough experience with this that we can pretty much do what we set out to. It's a little more boilerplate than I wish, but that's okay. Okay. So I think we'll take a break, 3 minutes or so, and come back and start the true implementation and see how that goes. So I'll see you in a couple. Hey, welcome back. Okay, so I've done this before. I think all I have to do is say new. Somewhere there's create a new library. Packages, maybe. No? New package. Tell you what, I'm going to find the documentation. I know I've done it before, but it's been a while. Create Swift package. New package. Did I go up here? Yeah, I don't think that's impossible. It generates the manifest. Yeah, that part I remember. Okay. Source files in source. Okay. I think I can do that. New package. I'm calling everything PCOM. Let's call it. How about pcombo? I'm already in a Git repository, so I think I'll forego that. Okay. Well, I think we're going to want this. Oops, lost it. Pcombo. Readme package. Okay. All right. So we got sources and tests. Combo.swift. Okay. And a test. All right. Let's run this. Make sure everything's okay. Logic testing, unavailable logic. I guess I need to choose a simulator. Let's test it on my Mac. While that's thinking, let's go back up here. Let's pull the other playgrounds. I know I have one of them open. Test succeeded, okay. Let's see. What did we do up here? Parse result. This is more what we want. Yeah, I think I want a separate result type. And I think I need to make, where's parse? This I want generalized. Excuse me. Okay. Yeah, let's. Now, what's the. Okay, I guess this is just protocol, and this is. Okay. I don't think it's too unfair to do this. All right. I gotta make things public more than I'm used to. I got very lazy on that. Okay, so I'm providing you a sample parse result. Ugh. And so it begins. Do I need to be public? Do I need a protocol for this? Maybe that's a better question. Result, but let's take this out of the equation for a minute. I don't know that we need a protocol. Type LEST equals target. Yes. We'll take this off for now. Okay. I don't think I need to do that if I just call this target. Okay. Now, I don't think I really need to test this. Match. I think maybe this is result. The result of a parse. Yeah, I think that makes sense. Okay. I'm not going to test that guy. But I am going to define this. result. I want parser. Okay, parser. Now, my question is, can I protocols do not allow generic parameters use associated types. Okay, so this is Swift 5.7 will allow protocols to have parameter types. This does not. Okay, but we will see what we can do this way. Associated type input. And this is array slice of input. Requires arguments in ... Parse result. I think this is parse result of target. Okay. Array slice off of an input. We don't need the int anymore. And the parse result doesn't need the position. But it does need the input. Remaining input. I don't know, I'm getting all these types right. This is rest and rest. Okay. Okay. How are we doing here? Needs two parameters. He needs target and input. Does that seem backwards? Kind of does. And I think input is just as good a name as remaining input. And I'll call this input, I guess. Input, and this can be called input. Okay. What do we got? I think, okay, parser takes a slice of input. It produces a parse result with target and input, or input and target. Okay. Now, I don't know. I guess I'm going to test. Okay, I think we're up to a test. Like this match parser. I think we're just going to give it one item of input, and it's going to tell us, which has to be equatable, and it's going to tell us, is it there? Okay. So the test is match this is interesting. Maybe, another one people use is satisfy. Maybe that's a better place to start. Okay. Right. So, we're going to define a parser called satisfy. And I almost think the lowercase is better, even though it's not quite. I don't know. I think it's going to be more readable that way. A little weird. All right. So what we're going to say is let parser equal satisfy. Three. Can it infer this? Satisfies this new parser we're going to create. And if you say satisfy dot parse some input, 3, 2, 1. Then we want to let result equal that, and let's check result dot input. Let's check result should be 3, and result dot input. And I'm not liking that name input. I'm thinking remaining. If you wrap that in an array, because it's a slice, then I would expect to get 2, 1 back. Okay, so we assume there's some parser that takes this closure and we parse with it against an input stream, and we expect to get this result back. And that should be an equals. And the remaining should be that. Okay, that all sounds okay to me. All right, this is not going to build. We know that. Okay, so, and I'm just going to build it here for the moment and kind of work it out. Let's make class satisfy. It's a parser. Okay. And, oops, well, we need a type alias or two, and we need a condition. Okay, it does not conform, yes. Input equals well, I think I can say input target. Then I may not need these. The input is array of int, and the target is also int. Okay, type satisfy. Well, I don't know if I can say input here. Target. Is that going to be acceptable? I don't like it. Yeah. Okay. Now we should still not conform. Add stubs. Parse. Okay. Now this thing takes, well, it holds a condition. So condition of type, and it's going to be input 1. Input goes to boolean. So we want to function from our input type to boolean. Okay. And all right. Has no initializers. Yes, we need an initializer. Init condition of input to bool. Okay. Okay. And, well, how do you parse this thing? Let's go over here. Okay. Well, we're just going to say if I don't want to worry about this part yet. Let's just worry about this part. If condition of input dot first, then we're going to return parse result match. Well, that's just input dot first, and this is input dot drop first. Let's just do that. Okay. Cannot convert input 1 to expected argument type target 1. Let's let them be the same. Input that first. I don't know. Okay. All right, I'm still not happy. Okay. Match is target. That should be fine to be nil. Can I return array slice input 1 to return input 1? Input is an array slice. I'm going to take the ones off where I can. Okay. Oh, it's got to be a parse result. Sorry. Being stupid. Okay. Yeah, I'm still not totally happy here, but yes, it does. Input type. All right, and then parse result remaining. We'll change the name here. Remaining and here. Okay, how's our test? Compile. Okay. That's something. All right. Satisfy that matches. Let's test one that doesn't. Fails to match. Returning nil. And remaining, I think, untouched. Let's see if we can just not consume it. And I think that succeeds, yeah, because we did return this here. Let's do input.drop first. Just to make sure the test will fail if we did the wrong thing. Build failed. Cannot force unwrap. Oops. Put it back. Okay, this is initial parser. Like I just want to get things moving. Alrighty. Okay, so I said I wasn't happy. What am I not happy about? Well, I think this result type, I don't think it takes into account everything we learned. One thing we learned, let's see, we had the other, I think we had three playgrounds, pre-com sum, erase. Can I put these in the same tab thing? Oh, good. Okay. Become erase. Yeah, this is what I want more. I would rather have an enum that has the stuff. Okay. Now the only thing I'm not happy with, I'm looking forward to a situation which is what if you had a parser that you just wanted it to return nothing? And there's no element to return. So this is like epsilon in grammars. That means don't match anything. It should always succeed, but there's no element. Okay, so we might... If you recall that that paper we looked at the other day, he had this function called pure that basically just returned a value in front of the input. He just returned the input with an arbitrary value assigned in front. I think we could do that if we had to. You would be forcing the input type to basically provide you a value that corresponded to nothing matched. But I think that's okay. We can work with that. But I would prefer more like this for parse results. So let's change this. I don't think it's well, let's make this look like the other one. Input and target. And if you match, we want to return the target and the input, type of input. Is it type of input? Is it slice of input? Maybe it's slice. I hate to embed that. But input, like I want it to be token or character or something like that. So this resulting type is going to be a slice. Ugh. All right, let's make this parse result 2 and parse result input target. Input target, okay. And then let's go to our test. Parse result, yeah, there we go. Parse result, so this is success, and this is failure. All right, and now this, well, I guess the result is parse result, well, let's just say success 3 and 2. 2 comma 1. Does that work? Global function assert equal requires it to be equatable. Okay, let's go back here. Assuming input and target are equatable. Parse result. Well, let's do the extension thing. That's equatable, but it's not going to be, right? Does not conform. Yeah, this is going to be equatable. And I think if that's all true, maybe we don't need this. No, maybe this is a bad way to go. Let's do I want to do I want to make this easy on myself, and it's not. This is not even compatible. This is not right because it's not a slice, I don't think. Oh, it is okay. It took it as a slice, so that part's okay, maybe. Caselet, okay. Else. I don't know. These things do create problems, don't they? We expect result dot. Sorry, we expect target to be 3 and whoa. to be 2, 1. Is that going to work? Okay, let's try this. Oh, this one's going to fail. Can I make parse result? It can't conform to equatable because it's got to require its inner types to be this. Okay, let's do the same thing. Failure's result is successful, else failure but got result. Okay, these should pass. We'll make them fail. Oh gosh, must not fall through. Oh, well, it's not aware of Xcode enough. Sorry, JUnit or whatever you call it. Let remove let. Okay. All right, let's break this. Second test should fail. Expect failure but got success. Good. And then if we put that back, that works. Let's do the same thing here. Hope this is not an error, just a warning. First one should fail and the second should pass. Okay, result was failure. Okay. Let's flip these around. Oh, I'm still failing. Okay. All right, these tests should pass. Yay. Switch to enum for parse result. Okay, so as you can see, I'm kind of trying to integrate the multiple approaches we took and make sure we can take advantage of the best of them. Okay, so parse result. We're not using parse result 2 at this point. We got the protocol parser, and this is just kind of junk. All right, test should still pass. Okay, clean up. Did code. I guess that's a refactor. Okay, we're on our way. All right, this is in our callers domain because that's the type they want to produce. This this we have, this we have, this we have with our revised approach. This is target. We did satisfy, which is sort of a simplistic version. Okay, what did we leave out? Well, I think we left out the case of empty input. Whoops. Okay, so we're going to try this condition minus 42. Well, actually, let's take the 3 case again. 3 on empty input. I don't know if I can put the type declaration here. Okay, and if you try that, we expect a failure. Yeah. I guess we're gonna do this. Okay, so we try and satisfy this condition. The input is empty. Really? This may not work. This may blow up here. No. Okay, good. Make sure we're running the right test. Test satisfy fail and empty input. Okay, did not blow up here. Good. Empty input. Okay, so I think we just need to do that in here. If input dot is empty, return failure. All right, let's run these tests again. Okay, let's see. Check for empty input. And actually, yeah, let's change this test a little. How about what if we do 1, 2, 3 of 3 dot dot dot. Okay. So 0, 1, 2. Maybe I'll just make them 0, 1, 2. 2. That's the indexes. And then we're fetching the contents starting at position 3, which is the end of the array. Okay, and I think that should still fail, but to me it's a more realistic case that you don't normally start with empty input, but you get there eventually. So wanted to make sure that covers. All right, now they're still refactoring. Okay. One thing is this is a mess. Okay. What if we say extension extension parse result? I don't know how hard that is. I don't know if I have to say my input types again, but I want to say check success. I'm going to give it a target. I guess I'm going to have to. Input target. Check success. Swift extend about generic extension. Oh, it's available in the original. Okay, good. Okay. We want the result of type parse result and let's call this actual of parse result. Oh, you're still not happy. Not used in function signature. Of input and target, and then we want the target. And then the remaining is array slice of input. Okay, and then this. I don't know if I can do this like this. We'll see. Success target remaining. Okay. Okay. Target conform to equatable. Oh. I don't think that's going to work. Well, what if I just put it here? Does it work? No, it is happy. Okay. But this, let's make these line up. Okay. Check success. Do we need to pass it in? Can we just not get self? Parser to check target. Cannot convert value of type target generic parameter of generic enum to expected type generic parameter of instance method. Maybe because one's equatable and one's not. Cannot convert Swift array slice of input to expected type Swift array slice of input. That sounds really unfortunate. All right, let's try the second approach. Let's just put a little helper function up here. Okay. Oops. Okay, so check success. We need a result of type parse result. Am I going to just specify the types? I guess int array slice of int. Input target. Input is the slice and target is the result. Okay. We need a result. We need a target int and a remaining of array slice of int. It's getting old typing int already. Remaining array slice int. Okay, I've messed something up. Parse result is int, comma int. Target and remaining. This is expected target. Expected remaining. Expected remaining. Okay, so we pull this from result. Let's call this actual. And again, I'm going to split the lines up. I don't know. I think that looks better down there when the 7s. Okay. Actual expected target, expected remaining. Okay. So I should be able to call check success result 3 2, 1. All right, this should work. Except cannot convert target generic parameter if it's doing parse result. Expected type target generic parameter of instance method. Oh, I don't need this extension anymore. Okay, try again. Okay, let's do some breaking. Failed. Result was failure. Okay. I've seen better messages, but I think that's okay. Let's do input.last. Error failed. 1 is not equal to 3. Okay. Set. Yeah, I can put a message. Okay. One is not equal to 3 target. Okay, good enough. Let's see. So that's fine. Let's put this code back. Good. And let's make a check fail. well, this may be short enough. This is actual parse result int. Okay, and the code was down here. Okay, equals actual. How did we get this before? I guess if we just return this, I don't know, that may blow up on us. And we probably have to call it. Okay. First one should pass now. Okay. Expected failure, we got success 3, something, something. Okay. Satisfied, fails to match. Okay. And then this one passed. Good. All right. And let's put it back. Okay. Alrighty. So I don't know. It feels slow to start this way, but I just kind of want to get this stuff ready and helpful. The tests themselves, they're much more readable. Okay, should still pass. Whoops. There we go. Push. Okay. All right. Now we have satisfy. That belongs over on the other side. It's in the test right now. Let's make a satisfy. And we may change this around, but just a Swift file. Okay. Check these tests again. Good. combo. Maybe this should become parser. I don't know, the boilerplate here. Hopefully that caught the rename. Good. There. All right. Let's see. So I've left off match. I don't know if it's, if you match one thing. I kind of hate the overhead of creating all these separate classes, though, I have to say. You'd have to give it the input. Yeah, I think we're going to leave this one off. If you want to define your own, you certainly can, and you can do it with satisfy without much problem. Okay, so that's pcom sum. All right, where's our other pcoms? This is erase. I think, okay, there's match again. Wrap we can defer. I guess the question is, what order do we want to go in? I'm getting a number of windows here. Okay, here's our to do. Okay, so we created a package. Yes, we've done that. All right, and we've created we created parse result, parser, and a satisfy parser. Okay, that's sort of a basic setup kind of thing. Now we have this list of operators. Oh, interesting error reporting. We haven't dealt with that. Okay, can it be tokens, try, erase, slice? Yes, I think we're happy enough with that. Use array slice. Okay. Now, what's the right order for these things? Well, this SEP 1 is kind of a good one, because many one, well, no. I was going to say many one can be implemented with SEP 1, but it can't unless we have that empty thing. We don't have the ability to do that. We can do the pure one that injects a value, but I don't think that's helpful. Okay, I think it's a good tool, but it's not a generic thing. Now many, optional. Many. Well, I think maybe or is the easy one to start with. All right. And I think this syntax is okay. That's okay. I don't know about that one. And many. and many one may need their own syntax. I'm thinking star star for many and star plus for many or one. Or maybe plus star, I don't know. And then this was thinking something like comma star. All right, let's do or else. I think it's a simpler one of what we have. Okay, and from the test point of view, all right, this is really satisfy tests because that's the parser we're checking. So let's rename this. Okay, run the test. Okay, and we want a new test case. And we may not even get the test done. New file. This is, oops. Oh. New file. Let's get a test case. Why they don't format this right, I don't know. I have to talk to John. Import cannot be used. There's an identifier here. Import XC test. Oh, it left off my package. P combo. Okay. And all right, we want to test an or else. Well, that tells me those little helpers are more generic than all right, let's set one up. Let or parser is going to be or else. The types. This is where it's P of parser. Let's find that other playground. Let's find or else. Two parsers. Well, I'm going to take this much. Sat1 equals satisfy $0 equals 1. Okay. I guess satisfy over int Okay. We have a satisfy parser that produces or parses ints. And we have an OR parser. Well, I don't know the types here, but it's certainly going to take sat1 and sat2. And the result is OR parser. Let's just call it parser. Dot parse of input 1, 2, 3, 1, 4, 5, and we want to check success. Result. We expect 1 to be returned and 4, 5 to be the rest of the list. Okay, cannot find OrElse in scope. Yeah, that's definitely true. Okay, we'll put it here for now. Okay, and I've got to, I don't know if I can let it infer that. And check success is not in scope. Okay, so let's make a new file. Just a Swift file. Oh, it didn't ask me for my name. Interesting. Parse result plus check. I'm going to put those functions in here. Satisfy tests. Have these two functions. Okay. Tests. Let's rename this. This is OrElse tests. Okay. OrElse does not conform to parser. Add stubs. Yes. Well, that's not helpful. Target equals P1. Has no member parse. Okay, we need a parse. All right, and I'm just going to take that out for now. Cannot convert value of type int to expected type array of character. Where did it get array of character? So it goes parse with array of ints. Something's defaulting to character, I guess. Int parse. Oh, we don't want position. Oh, yeah, okay. This is array slice of p1 dot target. Produces target and, well, it produces parse result. Of getting balled up here. Okay, it should be input type. I guess we need input type as well as the two parsers, don't we? And the parse result is input target. Parse result input target. Okay, input. Parse array slice of input goes to parse result input target. That should match this one. Parse array slice of input goes to parse result input target. Okay. Cannot return pause. Oh, this is parse result. Actually, I don't think we need the word parse result there. Okay. Input cannot be inferred. Well, this is int. Can I do that? No. Do I never call OrElse in an example? OrElse P1, P2, okay. Whoa. I think I just killed Xcode. No. Or else we let it infer it. Actually, we don't know if those worked, but I think I typed that this morning. Ugh, I hate having to type all these types. Types where else got specified. Okay, well, the next type is parser. Parser, but it probably wants more on that too, right? Where's our parser? Input and target. I don't think it's going to let us get by with that. Parser's type cannot conform to the protocol. What does that mean? What about sat1.type? Cannot find sat1 in scope. Okay, this is a test that OrElse can match first item. Should fail. I don't think he really ran. Okay, good. We'll call it a halt there for today. Next time, I'm not quite sure on my schedule next week yet. I will post a tweet. I'd say it's about 50-50 whether I'm going to be there Monday. Well, I've got company Monday, Tuesday, and maybe Wednesday, so I'm not sure what's going on in the mornings and stuff like that. So if I'm here, it'll probably be 10 a.m. to 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 UTC, and it'll either be Monday, Tuesday, Wednesday, or Thursday. I'm not quite sure yet, so we'll see how that goes. But thanks for joining me. I'm kind of glad to be in this phase. I'm a little put off by the extra typing we're doing to allow for input types. That's making me nervous that we're working too hard. But at any rate, I think we're making progress, and I'm happy to move forward on this and see if we can get a good library out of it. All right, take care. Have a good weekend. Bye bye.